Okay, so I'm going to talk quickly about the rate of radioactive decay. I don't have an awful lot to say about this. This is fairly quick and short here. So half-life is T1/2. That's just how we represent it. It's just the symbol we use for it. So it's the time required for half of a given quantity of a radioactive substance to undergo decay. So if I have a radionuclide, and it doesn't matter what it is, that has a half-life of 12 days, well, if I have 4 grams to start with, after 12 days, I only have 2 grams, because every 12 days, I'm reduced down to half of what I had before. Half of it decays. So we end up kind of entering, I don't know who here knows philosophy, but we kind of enter a Zeno's paradox a little bit. So bonus points if you know what that is, I guess. So in another 12 days, after 24 days total, we go half again. Only 1 gram remains. So I hope you're getting, what I want you to understand is that as time goes on, the actual number of particles that decay per day is going down. So it's a concentration issue, right? The less there is, the less decays. So the actual numerical amount that you lose in each half day is smaller as you progress. So in 12 days, I go from 4 to 2. In 12 more days, I go from 2 to 1. And after 36 total days, I will be down to 0.5 grams. So there's an equation your book gives, which is the amount of radionuclide undecayed after n half-lives equals however much my original is times 1 over 2 times n. N is the number of half-lives. So let's take a problem that the book gives. So it says iodine 131. So it actually doesn't matter, but I'll write it anyway. Iodine 131. Iodine 131 is a radionuclide that is frequently used in nuclear medicine. So the half-life is 8 days. That's the half-life. That's T1/2. That is the half-life. Okay, so how much in grams so my original sample is 0.16 grams. How much will remain undecayed after 32 days? So let's think about this. What you need to know is how many half-lives is 32 days. So if we want to use this equation, here's how I would do this. I need to figure out how many half-lives this is. So I take 32 divided by 8. That will tell me how many half-lives that is. And of course, that answer is 4 half-lives. So I take my 0.16 grams times 1 over n to the 4th to represent 4. Now, this doesn't have to be a whole number. It could be a fractional number. So I'm going to take 2 raised to the 4th, which is 16. I take 1/16 times 0.16, and I get 0.01 grams is how much I have left. So hopefully that makes some sense. So let me show you a quick graph here. Oops. There we go. So notice that the amount of decay slows down. So first half-life, we go from 80 to 40. Second half-life, we go from 40 to 20, 20 to 10, 10 to 5, 5 to 2.5, etc., etc. So here's a range of half-lives. So notice some are, a couple of years, some are a couple of minutes, some are, fractions of a second. And things like vanadium take, 10 to the 15th years to decay. So there's a huge range. Just because something is unstable doesn't mean that it's, gone instantly. But it can. All right, so I will talk about transmutation and bombardment in my next video, and I'll talk about it in class.